started. So this graceful failover feature compared to normal failover, or what we call forced failover, is that the graceful failover can ensure during the failover process, we ensure causal consistency, and we make sure there's no workflow progress loss during the failover process. I will first give a quick overview of how Cadence replication works and how forced failover works and what's the problems within forced failover. Next, we will discuss the new concepts and components we introduced in graceful failover and how it works from end to end, and how this new process solves the problems in forced failover. Next, we will go over the usage and some limitations of the new graceful failover feature. So in replication, we all know that when registering a Cadence domain, we need to specify, especially when registering a global history Cadence domain, we need to specify an active cluster name and a list of passive clusters. Once registered, the workflow will start, after workflow is triggered, it will start to make progress in this active cluster. And as the workflow makes progress, a list of replication tasks will also be generated and persisted in a replication queue. The passive cluster will periodically pull this queue in order to fetch histories and apply them in the passive side. In this case, the passive cluster on the right already have all the events applied. So its polling request will return empty because everything is already applied. On the left case, on the left passive cluster, since there's only 2 events replicated, the last one is not. So its polling request will return the last batch of events and then got it applied. So this is how, in general, how replication works on a high level. Now let's look at how forced failover works. In happy case shown in here, there's no replication lag, and the workflow state is exactly the same in the passive and in the active cluster. Try to do a forced failover now. The workflow will immediately start to make progress in the active cluster. Let's say in this case, it tries to schedule a new activity task. Again, this new activity task will generate a replication task, and the task will be pulled and applied in the new passive cluster. So it will be replicated back. However, things will get a bit complicated when there's a replication lag when we do a forced failover. Now consider this case where just before forced failover, we do not have this activity task applied. Now after failover, the workflow in the new active cluster will start to make progress immediately and possibly generate a new set of events. For example, in this case, since activity is only running in the old active cluster, it will likely get timeout after failover. But remember that the replication polling progress is continuing to happen. So the new activity timeout task will be also replicated back to the passive cluster. Since it's generated after the replication has happened, it will actually overwrite the previous activity task history in the new passive cluster. And similarly, the previous activity task will also be replicated to a new active cluster, but because it's an older event, Cadence, although replicated, it won't be showing history, but Cadence internally persists it just for completeness. The actual workflow code, in the actual workflow history, you won't see that activity task. So basically, the history got lost, and we won't be able to see it again. Activity as a simple case, there are also more complicated cases. For example, signal or start child workflows. In their cases, if we do a failover when there's a replication lag, it's also possible that you will see the signal appear twice in your workflow code, or maybe try to start the child workflow twice and result in some duplications. So this is actually the first problem with forced failover. Workflow progress might get lost, and duplicate events could be generated after forced failover. So our previous discussion assumes that there's only one replication queue in the cluster, but actually that's not the case. There will be one replication queue for each Cadence shard. Here, shard simply means a partition of workflows, and the workflow will be randomly assigned to a shard for processing based on this workflow ID. The processing within each shard is totally independent of each other, and it also applies to replication, which basically means the replication speed can be very different for different shards. So in this case, let's say a parent workflow in shard X wants to start a child workflow in shard Y. In the active cluster, we can ensure that this child workflow is started only after the parent is started. However, it's not the case in the passive cluster. Due to a replication lag in shard X, we will actually see the child workflow before the parent is applied, is replicated to the passive cluster. Now, let's say if we want to do a force failover right now, the child workflow, it will immediately start to make progress in the new passive cluster, in the new active cluster. And let's say this child workflow wants to signal parent to report some progress. However, in this case, the signal will fail because the parent doesn't even exist in shard X yet. So basically, in this case, we will see a very weird history in the new active cluster because we know the parent workflow must exist. However, the signal is failed. And after the replication got caught up, the history will be even harder to understand because we will see both the parent and the child, but the child still says it cannot signal the parent workflow. So this is the second problem of force failover. Since there's no coordination among shards, it will lead to causality issues after this force failover. So how graceful failover solves those two issues? First, to prevent lost progress, we introduced a new state called pending active state for domain. So instead of just jumping from passive to active for domain, in this new pending active state, all processing for domain will be paused and wait for the replication to caught up. And to coordinate the progress among different shards in the old active cluster, after we mark the domain as passive, we will insert a special replication task called failover marker into all shards replication queue. Note that since the marker is inserted after the domain becomes passive, there will be no new replication task for that domain inserted into the replication queue. Now, in the the domain will be waiting in this new pending active state and waiting for all the failover markers to arrive. And we have a new component called failover coordinator to track whether or not the marker is received for each shard. Once all markers are received, it will change the domain state from pending active to active and unblock the workflow execution for that domain. But remember, since this is a replication progress between two clusters, it's very possible that one cluster becomes unavailable during this graceful failover process. If that's the case, then basically we will never receive all the markers for all the shards. So for all the graceful failover requests, there will be a timeout associated with it. If we cannot receive all the markers within that timeout, the domain will be forced to convert to this active state. And so that this domain won't be blocked forever in this pending active state. But this also means it will be using a force failover and have all the problems I just discussed. And this timeout is tracked by a separate component called failover watcher. So this page describes the graceful failover process from end to end. It's the same as previous example. In this case, we still have the child workflow replicated first to the passive cluster and to the parent is not replicated yet. Let's say now we want to trigger the graceful failover. First, the domain will turn from active to passive in the left cluster and from passive to pending active in the right cluster. Then we will insert the failover markers into the passive cluster's failover queue, and the coordinator on the pending active cluster will wait for those markers to receive. So once it validates that everything has been applied and marker has been received, it will turn from pending active to active and unblock the workflow progress. And then the child can now signal the parent, and since the replication already caught up, the signal will succeed because parent does exist in the new active cluster. And then the graceful failover basically solve the issues we previously seen. So the usage of this new graceful failover is quite simple. It's basically the same command we use for force failover, and we only need to specify the failover type as graceful and specify the timeout in the number of seconds. In this case, I want to failover this domain using graceful failover with 5 minutes timeout. A couple of limitations for the new graceful failover feature. First, all clusters must be available and be able to talk to each other when we do this graceful failover. Second, when the domain is in this pending active state, all external requests will fail. For example, to start workflows or signal workflows, all those requests will fail because in order to handle those requests, we actually need the replication to be called up first. Because for example, for start workflow request, the result may be different after the replication called up. For example, previously we can return a success result, but after replication called up, probably we will need to return a workflow already running error. So during the pending active state, we won't be able to handle any external events or requests for that domain. Third is the gracefulness. Currently is only best effort, not guaranteed. This mainly because we have this failover thing, failover timeout thing. Once the timeout is exceeded, force failover will be triggered and will introduce the lost progress or causality issues I just mentioned. However, in reality, as long as all the clusters are available and can talk to each other, it's unlikely to happen. But theoretically, this is just the best effort feature. Cool. That's all I want to share about this Graceful Failover feature. So if you are interested, you can also read more in our cadence.io documentation about Graceful Failover. Thanks.